So in the previous video, we actually implemented our add-in order method, which was a way to iterate through the list of entries in our linked list. And we found out that the list iterator is great for actually going through linked lists and actually going through the actual entries one by one. But I just want to make a point before we move on and enhance this a little bit, is the first time you actually create the list iterator, like on this first line here, line 40, that's not actually yet pointing to the first record. So you actually have to use a string list iterator.next to go to the first record. So it's important to know that the first one is just a setup. It's not automatically pointing to the first entry. You need to use that .next first to actually get to the first entry. And the one thing I didn't do down here was I needed to return true as well. Return true. Because at that point, we know that things have been ordered correctly because we've been through these other tests here. So that's why I'm returning true there. And that obviously makes the method valid. So that's list iterator. That's just one method of actually going through and sorting our capital cities. And I just want to make a point that writing methods with side effects, such as using .next, is generally to be avoided. So unless you really know what you're doing, it's not a good idea to write a method that both returns a value and changes the object that it's called from. And that's what's happening in this method. So we're returning the fact that it's true or false, but we're also modifying the linked list that was passed by actually changing the actual entries. So generally speaking, you don't want to do it that way, but the Java people who actually created Java, they do have a pretty good idea of these things, and that's the way they've implemented iterators to work like that. But generally speaking, again, you probably wouldn't want to do it that way. So let's go back to our main class, I should say, and we'll put some code in and actually we'll test to see whether this actually works, and we can actually see the code in order in there. So we'll come back in here because we've got our code here already. We've got Sydney, Melbourne, Brisbane, Perth, Canberra, Adelaide and Darwin. So what we need to do to implement this is we need to just change this code a little bit. We need to add the method call to our add-in order, and we need to pass the actual linked list as well as the entry that we want to save. So I'm going to do something like add-in order, places to visit. So that's the linked list that we're sending to it, and Sydney. So we're going to be calling that method, and I'll just delete some of this so we can see what we're doing. We're going to be calling the method add in order. We're passing the linked list to it, and also the name of the city, in this case, capital city we want to add. So I'm going to do that for each one. So I'm going to do one for Melbourne, Brisbane, Perth, Canberra, Adelaide, and Darwin. So I'm going to go and change these. Melbourne, Brisbane, Perth. Incidentally, this wouldn't be a good order of actually visiting states, capital cities in Australia, because we're going sort of left and right of the country. So there'll be a lot of extra travelling, but it's purely there for actually demonstration purposes. Okay, so there's some. So what we then want to do, now that that's been added, we just want to do our print list again. So print list, and we're passing places to visit. So if we execute that, what should actually happen is we should get these actually added, or showing I should say, in alphabetic order. So let's just try that. I'm going to run that. And you can see that it's working quite nicely. We've got Adelaide, Brisbane, Canberra, Darwin, Melbourne, Perth and Sydney. So it's actually in the correct order, which is fantastic. And just to verify that, because of course the other thing we put in there, we actually put in this comparison down here. If comparison is equal to 0, to not allow a destination city to be added twice. So let's just test that actually works. So I put something like add in order, places to visit. And if we try, say, Alice Springs, well, of course, that should work because Alice Springs is not in the list. But if we do add in order, places to visit, Darwin, that should actually fail because it's already in the list. So when we rerun this again, we should find that Alice Springs has been added, but Darwin hasn't been added again. And we should see a message on the screen indicating that Darwin was not added because it's already included. So we'll paste that in there now so we can reprint that after we've added those 2 extra entries, or we tried to add the second one. Run that again. And you can see Darwin is already included as a destination. Now, the reason that message is coming up earlier than all the output is, of course, it's calling the add in order method first before we're printing it out. So you can see that Darwin wasn't duplicated, but Alice Springs was correctly added to the list. So you can see that linked lists are extremely powerful, and it's perfect for the type of data, in this scenario that I'm actually showing you, where we want to insert, where we're inserting records on a regular basis, or you're needing to sort things or something like that. This is a great way to be able to do that, to use linked lists for that scenario. So let's actually now enhance this a little bit more. So what we're going to do is we're going to include a menu, and it's going to allow us to decide when to move on to the next city. And we can also look at how to go back to a city we've already visited, because that's something we haven't talked about with linked lists. We've got this .next, which we had, I'll just close that down. The .next, which we had in our main or our add-in order method, and of course that went to the next entry, and we saw that on these slides that I showed in the previous video. But the way that this actually works, and the way that Java have implemented it, is seriously pretty cool, because what they've done is they've given you the option to actually go back in both directions. So you can actually go to the next record in a forward motion, the next, in this case, capital city, but you can also go backwards as well. So in other words, we could, if we're at Canberra, we could go back to Brisbane. And this is possible because Java have implemented the linked list as a double linked list. So in other words, it stores a reference to the previous item, as well as a link to, or a reference I should say, to the entry that's next as well. So that's pretty cool that it actually handles both of those. So let's actually add some code and implement that. We're going to add a method called visit, which gives you the option of specifying whether you want to go forward or back when you're actually searching. I'm going to come down here and create that method. We're going to call it, as I mentioned, visit. So private static void visit. And it's going to require, of course, the linked list. Linked list, and that's going to be our cities. So you've seen this before. We're going to add some scanner for some input. So scanner equals new scanner. Scanner, and it's going to be system.in. And we'll put boolean quit equals false, so we can set that to true if we want to actually exit. We want a list iterator of string, because that's our data type for our cities. List iterator equals cities dot listed iterator. So firstly what we have to do is we want to do a test to see whether there's no cities. So we can put if cities dot get first. And that's a way to determine or to actually retrieve the very first entry in a linked list. So if that is equal to nothing, that should be double equal, of course. We're not setting a value, we're actually comparing it. If that's equal to an entry, a null entry, if that's the case, we're going to do a system out, no cities in the itinerary. Like so. And we're going to return at that point. We don't want to do any more processing because there's nothing to show. And I'm adding this part to the video after I actually recorded the first bit. I'm not actually too sure why I actually did this first piece of code here, because this is not actually right. So .get first does actually get the first entry. There's no problems there, but the equals and then double quote is not a way ever to check for a string anyway. And actually in this case, it will return an error. So if we actually send this an empty linked list, it will actually return an error. The correct way to actually test this is actually to check using isEmpty. So we put isEmpty. So again, I'm inserting this into the video after, so use .isEmpty. So when this little component stops and we go back to the other video again, you'll see the old code, but ignore that and use cities.isEmpty in this place. And I'll also make sure I update that in the source code as well, that you can download if you ever want to check the code for any reason. Okay, back to the main video. Else, we'll actually put the name that we're visiting. We'll put so now visiting plus list iterator dot next. So we're actually moving to that first entry again. So get first enables you to get the first entry without actually changing the pointer, but dot next actually physically moves to that next entry. And at that point, we want to print the menu to give some options. We're going to create that method shortly. And then the actual loop is going to be while, not quit. So we're going to keep going until quit is set to true. Int action equals scanner dot next int, and we've seen a lot of this code before, so I'm not going to spend any time going through it. We've done this quite a few times. Next line, we're just going to clear the input line after that. I'm going to go through now and actually add a few switches. And what we're going to do is, firstly, case 0. So if they enter a 0, we're going to put holiday over We'll put holiday, vacation. In Australia, we call them holidays, but I know overseas it's often called vacation. And we'll put quit equals true. Break. And I've actually forgot in my haste to type ahead to actually put a switch on action. But of course, we need to do that. And I'll paste the case in there. We can continue going. Okay. That's what I should have done right the first time. Okay, so if you enter a 0, then the vacation's over. If we enter a 1, we're going to do the following. We're going to go now visiting. We're going to move to the next one. Now visiting list iterator.next. But what I need to actually put is put a test there, of course, to actually check we can do it. So if list iterator.has next, so we can only go to the next one if there's an entry there, then we need to do it that way. Else, we're going to print some output to say reach the end of the list. So in other words, we've got to the last city in the list at that point. So we're going to keep on going if they select 1 to do just that. And of course, importantly, I need to add a break as well. I'm just going to move this up a little bit so we can see what we're typing a bit better. Okay, so that's case 1. In case 2, we're going to do something we haven't seen before. We're going to go back to the previous entry. So we're going to put case 2 if list iterator dot has previous. Previous goes to the back, as you would suggest, or goes to the previous entry. I'm going to put now visiting this iterator dot previous. Else we are at the start of the list. So you can see what we've done there. So if 0 is typed, we're going to end the holiday. So that's our way of exiting out. If 1 is typed, we're going to go to the next entry, the next city in our list. But if 2 is typed, we're going to go back to the previous entry. So in other words, then we also need to do a test to see whether there's previous. And we also have to do list iterator.previous as well. And just to be clear, because we're doing a .next, you might be wondering, well, how does it know that it's a string? Well, if you recall, when we actually at the start, when we defined the list iterator, we actually said it was of type string here. So consequently, when we're going to print this out, system.out.println, it knows .next, it looks at that and says, oh, okay, that's a string, and that's why it can actually print it out. And that, of course, is the same for next and also for previous. And then case 3, we're just going to add, I need to add a break there. Case 3, we're going to add just to redraw the menu in case it's gone off the screen and you've forgotten the options. So I'm going to put print menu and break out of that as well. And of course, we haven't implemented that yet. Okay, so that's the basic the basic visit class. What we need to do is now implement that print menu as well. And that's going to be very basic as well. So we're going to just go into here and we're going to just do a private static void print menu. I'm going to put available actions, press, then we'll go 0 to quit, one, go to next city, 2, go to previous city, and 3, print menu options. So that's our print menu. So let's now try this. Let's now add the code to actually start the visit command. So we're going to just actually call the visit method, I should say, I said command, and check that just to see what happens. So we're going to put visit, places to visit. So if we run that now, okay, so available actions, you notice it now says now visiting Adelaide. So if you go to the next city, type 1, now visiting Alice Springs, go to the next entry, visiting Brisbane, next entry, visiting Canberra. Now if we try to go back to the previous city, we notice there's a problem. And notice what's happening. Why did it actually double up there? Actually notice that it seemed to not work and then it actually started going back in the right order. Well, the problem is that Java does not implement the linked list in quite the way that we've actually described. Now there's actually an explanation of the list iterator. I want to just show that you on the screen to help you sort of understand how this actually works. So let's just open a browser. I'm going to paste this link in There we go, that's the list iterator. And if you actually go through here and actually have a look, you'll see that the problem actually is that there's no current position as such. So the list iterator actually hovers between the items that would be returned when you go to previous or when you go to next. So if you go forward with one and then go back with two, then go forward with one, etc., you never actually leave the city that you're actually in. So this is actually a problem. But there actually is a good reason for this. So if they had have actually allowed access to the item at .next or previous in the normal way, then an error would actually lead to loops in the list. For example, if we'd made a mistake while removing Perth from the list, we'd end up with something like this. And I'll just show this on the screen. And we'll just go to that entry. So in this scenario, if they had left it how you would think it would normally work, then traversing the list would then return Sydney, Alice Springs, Melbourne, Brisbane, Alice Springs, Melbourne, Brisbane, Alice Springs, Melbourne, Brisbane. So it's sort of like an infinite loop. And of course, we don't want that to happen. So this is like a really sufficiently serious problem in the past that algorithms have been developed for detecting and fixing loops in structures like linked lists. So you can Google something like tortoise and the hare algorithm. If you want to do that in your own time, you'll see that there's actually a big issue with that. And that's with this linked list sort of looping over itself. But the great thing is that Java have set it up in such a way that that is not going to happen to you. So it doesn't really allow you to make that type of mistake where you'll get into a loop. But what it does mean is we need to keep track of which direction we're going and allow for the in-between nature of the iterator. So in other words, there's a little bit more work that you need to do to get that to work. But in the scheme of things, it's not really that hard. So let's just go back and modify that code to get it working correctly. So what we actually really need to do is go back to our visit method, and I'll close down this to make us a bit of space. I'll disconnect it to close the program down. We need to go back here now to our visit, and we need to add another variable. We need to put a variable to track the direction. So we're going to call it going forward, and I'll set that to true. And what we need to do is when we're going forwards or backwards, we need to do a test and we need to set that direction. We start off with the first one, which is going forward, case 1. So we're going to put if not going forward. So in other words, the user has previously selected going back. Then we need to do a test and put if list iterator dot has next, list iterator dot next. And then going forward is equal to true. So we're doing that additional check to actually make sure that we actually can go, that there is the ability to go next and then actually go to the next entry again so that we can actually continue where we left off. So it's actually that extra step that I talked about to make sure that you don't get into that scenario where you're doing a loop. And likewise for going backwards, if it's actually going forward currently, then we put if list iterator dot, if it's got a previous record, then we go to the previous entry, like so. And of course we set going forward equals false. So just as a recap, again what we're doing is we're actually setting this up. If the user has selected to go forward, and if we're currently not going forward, we check to see whether there's an entry we can go forward to, and we set it to go there. That sets us up in the right direction so that the following code actually works. And the other thing I'll need to do here is the end, going forward equals false, because we've reached the end of the list, so there's no more way to go forward. So we're going to set that to false once we actually have reached the end of the list. And likewise, if we get to the start of the list, to the very first entry, we need to do a similar thing. We need to set going forward. We need to set that to true, because that's the only direction we can go now. So we've reached the first entry, so we automatically change the direction to pointing forward again. So you can see what we're doing there. So we're just controlling the state. We're just doing a little bit more housekeeping to make sure that in the event that we're going in a particular direction, once we reach either the start, in this case with the going forward. So in this case, if we're actually are going forward, what we're doing is we're doing a test to make sure that if we weren't going forward, prior to the actual menu option being selected, we need to point in that direction to be going forward. But also if we get to the end of the list, we need to set going forward to false, which means that from now on we'll be actually navigating going backwards. And we're doing the reverse in this scenario with case 2. If we were going forward, but the user has selected to go previous, then we need to check whether we can go previous. If we can, we go to that previous entry to point it in the right direction. Then we set our flag to the fact that we actually are going in a backwards direction, going to the previous entry. And likewise, when we reach the start of the list, the very first entry, we can't actually go to any other previous records because we're at the first one. So we set going forward to true. So hopefully that sort of makes sense what we've actually done. So there's actually an extra check. There's an extra .next you need to actually use in a .previous if you're moving from one direction to another. So just to confirm that's working, let's actually run it. So let's just try it now. So you can see we're now visiting Adelaide. So I'm going to go to the next city, Alice Springs, Brisbane. So let's go back to the previous city now. Alice Springs, Adelaide. We're at the start of the list, so we're not getting an error there. So now if we go back, I'll go to the next entry, or next city I should say. We're back to Adelaide again, because that's the first one in the list. One, we can keep on going. We reach the end of the list, so it's not actually letting us do anything. It can let us go further and it's not crashing, and we can go back again and it goes backwards just fine. So that's actually it. That's how to actually achieve that and to get a linked list working. So I hope you actually enjoyed that. It can take a little while to get your head around linked lists, but they are extremely powerful, and especially with the way that Java have implemented them to avoid you having to get into this scenario where there's an infinite loop that we talked about in the PowerPoint slide. So you don't need to worry about that. You just need to do a little bit more housekeeping if you do want your list to have the capability of going to the next entry in the previous entry, but you've now seen that code. So in the next video, it's time for a challenge. So I'll see you in that next video.